All right. Hello, everybody. Welcome back to another vBrownBag. Continuing our series with a lot of the AWS community heroes. Today, we are going to talk about the serverless mindset, courtesy of our presenter tonight, Matt Morgan. Before we get on to the presentation, though, just a few housekeeping notes. If you're joining us for the first time live, please engage with us tonight. You can use the Q&A or the chat here in Zoom. I'm going to request people use the Q&A if they have questions. That would be great. But if you end up using the chat, it happens. It's all right. Also, you can also make sure to just engage with us on Twitter. You can use the hashtag vBrownBag today if you've got something clever to say that you want the world to know about. You can do that. I will be monitoring the hashtag on Twitter, hashtag vBrownBag, and you can ask your questions, make your comments there as well. We'll make sure to bring them up during the broadcast tonight. If you're watching this after the fact on YouTube, however, make sure that you check us out live. We have shows in multiple time zones for multiple regions and multiple languages even. This is the US show. We do it every Wednesday at 7:30 Central, 8:30 p.m. Eastern on Wednesdays. But we have other shows in other languages, so be sure to check those out on our website, vbrownbag.com/brownbags. Those of you joining us live, if you didn't know that, we have this series on YouTube as well. Be sure to check it out. We have tons of past videos on just about everything from cloud to VMware to serverless like tonight, Python, Kubernetes, you name it. If you have something interesting to share that you'd like to share with the community, maybe we've done it before, but it could use an update, or we haven't, and you think it's worthy of being on our channel to share with the community, please reach out. You can reach out to me. I'm Ken Nalbone on Twitter, @KenNalbone. Doesn't have the space like the PowerPoint says. That's my mistake, typo. But my DMs are open, or you can just DM the vBrownBag account, @vBrownBag on Twitter. But that's about it. I'm going to pass it over to you now, Matt. Are you ready?
I'm ready.
All right, cool. I'm going to click stop share and let you take over.
Okay.
I'm going to turn off my video so people don't have to stare at my face anymore, but take it away.
Okay. All right. So now you should be seeing my share.
We do.
But my presenter notes went away. That's a bummer. Let me just try to fix that real quick.
All right.
All right. Now you should see my share with me seeing the presenter notes, right?
I do not see presenter notes, but I do see your serverless mindset title screen.
That was indeed my intent. Thank you.
Perfect.
All right. Thanks a lot, Ken. This is really exciting. I'm super happy to have this opportunity, and this is a new talk. I've been working on it and sweating over it for the last 3 weeks, so I guess let's see how it goes. I think we'll pause for questions a few times. I would really appreciate your questions and to interact with you, not just now, but in the future. That's why I put my Twitter handle there, which is a little bit weird. It's @nullishcoleus. Don't worry about that. I'm going to share my website too, and you'll be able to find me. I work as a director of software engineering at PowerSchool. PowerSchool is a company with a whole ton of different products, many different technologies. But in my group there, and in a few others, we really love serverless, and and that's why I kind of wanted to talk about this and share some of the things that we've learned so far. Also, we're hiring in the US and India. So if you like the topics on this show, then you may be interested in what we have to offer. All right. I named this talk the Serverless Mindset, which isn't my unique idea. It's actually something that's been talked about a lot, but I just really had this on my mind when when I signed up to give this talk, and I thought it was like a really interesting topic to me. It's a little bit less of a direct technical topic where I'm going to show a bunch of code, although I'm going to show a little bit of code. It's a little bit more conceptual, like what are the things that make people love serverless and be successful in that world. I'm not going to try to exactly to define serverless. I think that some other people have done an okay job at that, and it's kind of all constantly evolving. I may take a swing at it. If you're really confused about what I'm presenting here, then maybe I do need to back up and try to provide that. So I'd appreciate that feedback. But yeah, I'm going to talk a little bit more about, okay, so here's serverless. How do I approach it? And what's the thought process that I think works really well there? I myself am a relative newcomer to serverless. Lambda celebrated its 7th birthday. It's kind of like AWS Lambda is one of the more important, I guess, services out there in the serverless space. It's kind of ubiquitous with the concept of serverless, although it's certainly not the only way to do serverless. I've only been doing serverless for about 2.5 years. But in that time, I guess I went really deep. I work with a lot of different developers, and I really like to help them to come to and explore serverless. I've probably introduced it to something like 100 different developers and help them to appreciate it and become successful in using that technology. And it's really a great part of my job, and probably my favorite thing to do, which is why I'm doing this outside of work hours now. I'm going to talk mostly about AWS serverless in this talk. That's not because I'm telling you to use AWS over other clouds. Other clouds are starting to come out with some really great serverless products too. The reason that I'm focusing on AWS here is solely because that's the one I know. That's the one I use in my day job. That's the one I've spent the most time focusing on, and so that's the one that I'm more or less qualified to talk about. But I'm not trying to be prescriptive or to say that Google Cloud Run is no good, or that I'm not interested also in Azure Durable Functions, just to name a few. So yeah, my motivation in giving this talk is that I hope that I'm going to be able to connect with people who are interested in serverless, or maybe haven't quite found their way there yet, and help them to learn, what's good about this technology and how can they be successful. I also am hopeful that some of my friends from around the community will either participate here tonight or watch this later on and give me some feedback about this, because I think that thinking about serverless as what's good about it, how do we approach it, what is our thought process here. Now, this is mine, and this is based on my experiences and what I think works really well. Other people may have some different views, and we can kind of come together and help to define that serverless developer experience and that serverless mindset that really works for us. All right, so that's my goal here. My topics. I got a lot of topics that I'm going to go through. The first one I call the platform as a cloud. Code as a liability is something that we like to say in serverless. Scaling is horizontal. We're going to go beyond function as a service. We're going to talk about routing or single purpose functions. I'm going to explore service limits and suggest why that might actually be a good thing. Talk about orchestration versus choreography, which is an interesting subject in this space. I'm going to talk about why you might not want to bring your own network when you're in serverless. I'm going to go over IAM, talk about item potency in serverless, pay per request, and why we want to scale to 0, how to test serverless applications, what the serverless developer experience might be like, and how to get started in serverless. And then finally, serverless gets better with time, and that's why we're so excited about serverless. Okay, so that's a ton of content. I hope we can get through all of it. I'm going to go kind of fast in order to see if we can do it. All right, here we go. So my name is Matt Morgan. I live right now in Maryland in the USA with my wife and daughter and 2 cats. But I grew up in northern Minnesota. I really like games, all kinds of games. When I'm not working, I spend time playing games, mostly with my daughter and my friends. I also like kickboxing, and I play the guitar. That is not a picture of my guitar, but I have one just like it. I was too lazy to snap my own, sorry. A little bit about my tech journey. We're gonna go really quickly here. I kind of got started writing applications way back in 1999. I used Cold Fusion at that time, which some people sneer at Cold Fusion in this day and age. All I have to say is that I learned how to protect against SQL injection attacks right away. So I thought that was a pretty good thing to start off my career and carry forward. Not because I had a problem. Anyway, I mentioned this because I had a non-traditional background. I didn't have a CS degree. I didn't have any prior training to this, and I sort of just got a job because it was the .com bubble and everyone could get jobs. And I like to call that out because people that interact with me today don't necessarily know that about me. But I really think that all kinds of different developers need to embrace people with non-traditional backgrounds. I think people with traditional backgrounds, of course, can also be really excellent, but people with non-traditional backgrounds really bring a lot into tech. And so I always want to support them. Okay, so really quickly, I got into Java a little bit later, started using some UI frameworks, mostly hated them, but we got by. I started getting into Node.js in the early years, and I was really interested in that ecosystem and what makes that go. And then I started getting into TypeScript because I wanted to level up my JavaScript and take it to the next level. And of course, I worked with a ton of different database and storage technologies in those years. Speaking of TypeScript, I co-authored a book on TypeScript that came out last August. I also do a ton of writing on different blogs and things like that, mostly in dev community, but I've also contributed to 100 Days of Cloud and Free Code Camp. All of that is available at my website. Now, I named my website a little bit better than I named my Twitter handler. And my website is mattmorgan.cloud. So if you go there, all my stuff will be collected. When this talk is posted on YouTube as a video, I'll also link it there. I will link my slides there and everything. So I just like to keep all my stuff in one place, and that is the place. So really quickly, again, my cloud journey, when I started in tech, the web server for my Cold Fusion application was on my desk next to my workstation. We leveled up a little bit after that. Started putting servers in a closet down the hall. And then we started using data centers, of course. So this is heavy data center time. Everyone was in data centers in those days. And toward the end of that, we started discovering platform as a service. I used a PaaS product called Joyent for a little bit, and started liking that as opposed to having to manage and run all the infrastructure on my team. In 2017, I had the opportunity to do a data center migration into AWS, and I've been pretty much focused on cloud technologies since then. I'm also an AWS Community Builder. The AWS Community Builder program is a pretty awesome community of people. It is not something that you can join at any time, but there are twice a year there is a sign-up opportunity. It's not currently open, but there'll be another one in the fall where anyone can put in an application and try to join the Community Builders program. So I joined back in 2020, made a lot of friends there. And the highlight of my experience so far in that program is attending reInvent just last December, where a bunch of us gave some dev chats. And anyway, it was really cool. I got to meet people in person in the middle of a pandemic, and it made things great. We just started doing a whole bunch of new projects and talking about like how can we contribute more to this to the community. So stay tuned. Watch the AWS Community Builder. Shout out to my friends there, and there's a lot more great things to come. Okay, last journey slide, I promise. I actually started using serverless technologies back in 2012, although I didn't know it when I started using an S3 bucket for object storage in order to store some uploaded content to a CMS. I was totally blown away. I didn't have to manage a file system in order to do this. It's an amazing technology. A little bit later, I didn't ever really use this professionally, but I started experimenting with Firebase from Google. To this day, I really love Firebase. I think it's an awesome technology. It's a great place to start if you are, this is like kind of my only aside from AWS, my only real experience with a non-AWS serverless technology. Firebase is really cool. It's basically a database in the cloud that has some authorization capabilities, a lot of other features, and it lets you build a pretty cool serverless application very quickly. In 2019, I was not yet really using serverless very much, but a colleague at work wanted to solve a problem using AWS step functions. And so we gave it a shot. We implemented a workflow using AWS step function. It was so good that I never looked back. I just like, give me all the AWS technologies, give me all the serverless technologies going forward. All right, so we're finally into the real talk. And my first topic here is the platform is the cloud, which is my way of thinking about this, about a way that serverless developers have a different expectation from some developers in some other technologies. All right, I'm not trying to generalize. There may be other people that see technology in the same way, but in my experience, when working on servers like EC2, which I certainly have done, a lot of the time, the first step in terms of building out an application is you've got an infrastructure team that is going to build the platform. They'll have some sort of manifest, some sort of infrastructure as code. It might be CloudFormation, might be Terraform, something like that. Hopefully they're using something good like that. And they're going to provision the infrastructure. They're going to create your load balancers. They're going to create your instances. They're going to create your RDS, maybe some scaling groups, whatever it is you need to build your application. And then later, the dev team is going to come and they're going to deploy the application on top of that platform that was built by the infrastructure team. And it could be the same people if you're a really small company, but if you're of really any significant size, it's usually different groups that will do this. So the dev team, both these teams probably use some sort of pipeline to deploy, but it could be totally different technologies that are behind this, and often the two groups don't understand each other's technologies super well, which is, maybe okay because these things are complex and we need to control our cognitive loads. But sometimes that causes problems just because because people don't understand everything that their application is running on. In the serverless mindset, now this one is pretty universal in my experience. The expectation is that there is a single manifest or a single description or a declarative statement that says, this is the whole application, this is everything. All right, so this is what I have on the screen here. This is a simplified SAM template. SAM is this serverless application model from AWS. And this is a SAM template. I cut out some of the bits in order to make sure that it fit on the screen, but I want to highlight what does the SAM template do. So first of all, we can take a totally blank AWS account that has nothing running in it at all, is not pre-provisioned in any way, no networking, nothing, and we can use the SAM template to deploy a serverless application into that account. So for example, here, this line is going to provision the Lambda instances that will be used to run the application, to run the compute part of the application. Here, we're going to provision a DynamoDB table. So that's going to be the database for the application. Right here, we're creating an IAM policy that is going to allow this function to read from the table. Right here, we're going to create an API gateway. That's going to be the way that the traffic from the internet is going to be able to reach the application. This is routing. So this is being built like, how does the API gateway route to the application? This is how. If the path is /hello and the HTTP method is get, then it will reach this function. Otherwise, it's going to give you some kind of error. And then finally, right here, now that's not obviously the function code, but it's a pointer to the function code. And when the SAM template is executed, it's going to bundle up that function code. It's going to put it in a zip file. It's going to upload it, and then it's going to make that part of the application. So it's all one step. That's the point, is that one developer can write this SAM template, can write the code that gets executed in Lambda and deploy the whole thing all in one step. So that's why I say the platform is the cloud. So all we need to start is the cloud. Now that there are no end of exceptions to that idea. Often, if you're in a largish company, you will do some sort of pre-provisioning. You might have like special roles or permission boundaries, or you might have to do a CDK bootstrap if you're using that technology. So it's not perfectly clean, but it's pretty clean. I mean, the point here is that the team that owns this template basically understands everything that they're building. Okay, so that's, again, in my opinion, that's the serverless mindset. All right, next topic. Unless somebody wants to shout out a question for that one, I'm going to keep moving. So the next topic is code as a liability. I don't know where this comes from originally. I know that Matt Coulter said this on the stage at reInvent 2021. I know that Jeremy Daly says this in almost every single one of his podcasts, but I don't know where this comes from originally, but I think that this is also key to the serverless mindset. So I'm going to show probably no end of examples that I could show this, but let's say we've got some sort of processing, right? So we've got a function that's going to go and get all the jobs that we need to process. Then we've got a loop that's going over them. We're abstracting away the actual work here. We're just going to wait for it to be done. And then we've got some kind of exception handler that's going to put all that back together. Now, if you think about that job being somewhat complex and having multiple places that it could fail, the implementation, never mind the implementation of the job, the implementation of pick up the pieces could start to get pretty hairy. Like, what happens if this is being executed on an EC2 instance and it goes out of memory and it crashes or something like that? How do we know where we landed in the job? What happens if there's a scaling event and another instance picks up the same job and now it's being run twice? What happens if we have some sort of race condition where the system has a difficulty determining whether or not the job is complete or not? What if there's a database outage in the middle of this? How do we recover from that? What if we get a row lock and suddenly we're not able to process anymore and the jobs just start piling up? Now, all of these things have solutions that you could implement, and we could write a bunch of code to do that, and we could maybe do that successfully. But in the serverless mindset, you don't want to spend your time writing those kinds of things. Sorry, I jumped ahead just a little bit too fast there. Writing all this custom code for managing job state or for tracking a workflow or something like that. If your product is a workflow engine, then you should do that. You should spend your time writing that kind of stuff. But in the likely event your product isn't a workflow engine, you're really better off if you can offload that in some way. So this is an example of AWS Step Functions, which is probably my favorite service to work with. And so AWS Step Functions is state machine as a service. And so I'm sort of using this diagram, which I actually built in the AWS console, to show kind of the same application, but how error handling and things like that might happen. So here I've got a Lambda function that goes and does the work. I think often we might implement that in multiple functions. I can show what that looks like in just a second. If that fails, there's a little bit of logic there that determines whether or not we should retry it or not, and then it can automatically retry. Now, I put this in the diagram to kind of demonstrate what that looks like, but actually, this happens automatically. It happens automatically in a lot of different places. I'm going to talk a little bit later about what the implications of that are. But you can see that, okay, so we just acknowledge there's a lot of learning that would have to go in to be successful with a technology like this if you haven't used it before. And I certainly went through that. I had to learn how to step functions run off something called ASL, which is not American Sign Language. It's I can't remember what it stands for actually, but that's the AWS state language, I think. Yeah, something like that. It is a fair amount to learn, but it offloads so much complexity from you, and now you can just focus on writing the application logic, the thing the cloud can't do for you because it doesn't understand what your job is. That's the part that you need to work on. You don't need to work on retries and all this. The other thing to mention here is that I'm showing here a map state. In my prior example, we were basically executing a job and then taking the next job and then executing that one. This one would work in parallel. So this means this is a fan out. It's pretty cool ability. You don't have to write very much code to do something successfully like this. Now we could have done that in the other one, but we have to then worry about if it's running on an instance, like how wide can we go and those kinds of things. Now, I'll get into service limits in just a second because we do have some of the same concerns here. But the point I'm making is that serverless developers really tend to prefer this and want to go for this kind of mindset. So I'm going to just go for I forgot I had some notes. Oops. All right, so this is another diagram that I put together. this closely resembles an application that I actually worked on. And the problem that we had to solve was that we had an unknown number of, in this case, I'm saying customers, it was something else. And for each one of those, we had to query 2 different databases and make an API call to get all the data, to stitch it together, and then render a template. And that template might get printed as a PDF, or we might do something else with it. And we needed to do this at any scale, right? That's a pretty complicated job, especially if you're going to write that as one process. You just imagine what that would look like if you're just writing that as a single loop. It could get really quite hairy. But we used step functions to implement that, and it was challenging because this is a challenging workflow. But now it runs really, really well, and it's a great experience. All right, so those are the steps. That's what the application is attempting to do. I want to talk about scaling. I want to pivot just a little bit, unless anyone has a question about that. Doesn't look like it. Okay, so let's talk about scaling. One question that people often ask when they're new to serverless is, how do I get a Lambda function execution to last longer than 15 minutes? And the answer is currently today, you cannot. Google Cloud Run just extended their time limit from 9 minutes to 60 minutes. So maybe AWS will say, well, actually, yeah, we should go for an hour or 2. Maybe they will, maybe they won't. I really don't know. I don't have an inside track on that. But right now, the function, when it's invoked, it will automatically be cut off at whatever your time limit on the function is set to. But you cannot make that time limit longer than 15 minutes today. So it just stops. It stops, it returns, it says, sorry, I timed out. You don't get whatever it was you were trying to do. Now, the serverless mindset, most people that I've encountered, and I know that someone's going to yell at me for saying this, we don't care about this. Generally, we generally don't care to try to make a Lambda function last longer than 15 minutes. I struggled with this briefly when we first started, and someone on my team was trying to run something that was, like sometimes it lasted 10 minutes and sometimes it lasted a little longer. And I said, we need to break this down. We need to make the functions smaller and make sure that we're not even bumping up against the limit, and that isn't really a problem. And now over 2 years, it just really hasn't been a problem. So how do we scale? We scale by distributing workloads. We scale horizontally. We scale by going wide. We scale by breaking things down into small units and then running them in parallel. And I just showed you with the step functions map state how easy that can be. We also scale by implementing asynchronous messaging. So I'll get into a little bit more a little bit later here, but using technologies like SQS, Simple Queue Service, or EventBridge, instead of saying, well, I just have to run this process until it's done, you say, I'm going to register an event and I'm going to send it, and something else is going to pick it up and it's going to process that. And then at some point, some later point, the job is marked complete. If you start making things asynchronous and eventually consistent, and this is a really interesting thing that even before I got into serverless, I always wanted to push things in that direction, because if you try to make everything synchronous, if you try to do very complicated things like how many payment systems are implemented where they're completely synchronous, and the money, you click pay and the money is actually transferred, before the web page refreshes and tells you that it was successful. I don't think any of them do, right? Because they know that that's complicated and can fail, and they try to manage that asynchronously. I think about the same thing, like almost any time I do something that seems a little complicated or might run long, let's make it asynchronous. And serverless is a great fit for that. Serverless gives you lots of tools to start making things asynchronous. And once you do that, you no longer have to worry about time limits all the time. It makes life a lot easier. You can also throttle. You can say, oh man, like all these people click the button at the same time. If the effect of clicking the button is simply that you're registering an event, I'm just firing off an event, and then that goes into some sort of queuing system, or it goes across EventBridge. the processing of those later on can be throttled, and you can avoid having your system get loaded because something exciting went on sale or something like that. This is how to scale in serverless, and I think it's awesome. I think it's really fun to do things that way. Another thing, if you have to go really big, you might think about multi-region. AWS has lots of most of the cloud providers support multiple regions. It's pretty complex to do that, so I wouldn't just do that without having a good reason to. But you also go to the edge. Like, this is something that's actually pretty common when it comes to static sites. Back in the day, we used to run Nginx or something like that on a web server, and it could get pretty slow if it was taking a lot of traffic. But today we use some kind of CDN like CloudFront or Cloudflare. You can actually run compute at the edge. Cloudflare has I can't remember what the product is called, but there's actual function execution, and so running code at the edge can get you just massive scale because these are global CDNs and everybody's got a local copy. You don't get all kinds of latency. Databases get a little tricky. I'll admit that, but there's really quite a lot you can do there. And even if you're just offloading, get rid of that Nginx server and use a CDN for your web assets, you're gonna offload a lot of your load, and you're going to be able to scale much greater. So I also wanted to mention elastic versus scalable. Of course, we want to be scalable in whatever system we're working in. Serverless resources are elastic, which means that they bounce back, right? So if you are using Lambda and you have a huge number of executions, and then those executions are done, those Lambda instances just go away automatically. I mean, you don't pay for them, and they're just gone. It's true, you may be aware that after an execution, a Lambda function will hang around for a little while and be ready for another request, but you don't pay for that if that request never comes. And that's what serverless developers love about this kind of thing, is that even if you go really big, you might be aware that serverless compute tends to cost more per second or per millisecond, but those resources go away so quickly, and you just don't have to pay for them after the job has been done. So elasticity is really cool here. All right, I want to touch on, again, I know I've been talking for half an hour now, so I don't see any questions, so I'll keep plowing through it, and maybe we'll do the Q&A at the end. So function as a service, it's often talked about in the context of serverless. I'm not setting out here to define serverless, and if you're using function as a serverless and you tell me that you're being serverless, that's fine. I'm not here to tell you that that isn't serverless, but I'm saying that serverless goes beyond that. So there's a lot more that serverless has to offer here, and just in terms of all the different native services. So so I was already obviously talking about step functions. Step functions will execute Lambda functions, but they will also do all kinds of service integrations. There's a lot of other things that you can do that get you out of that code, that where you don't have to have your code be a liability for you, but instead can take advantage of native services. Here's a few examples. There's not nearly as many examples here as I could put together, but things that will take advantage of native services and get you out of having to write code or function as a service. So like token authorizers are a pretty cool part of API Gateway. You can instruct API Gateway to automatically validate a JSON web token. And in doing so, you don't have to write any code, just a little bit of configuration. And further, you don't pay anything for the execution. So obviously, there's servers and serverless, right? Something in the background is running a process that goes and does that token validation. Well, you don't pay for that compute that's doing that. That's part of the service, and it's free in this case. You pay for the API Gateway execution, but you do not pay for the authorizer. Step functions. All right, maybe you've heard enough about step functions already. API gateway validation is another one that I really like. I think it's probably a little bit underutilized, but you can actually put models in an API gateway and say, I expect my data to take this form, and then return a 400 error if a request doesn't match that. Again, that's outside of your code, and you don't pay anything for the compute. There's obviously AWS is running compute to do that, but you don't have to pay for that, which is really quite good. DynamoDB has a time to live attribute that you can set, and you can just say, you know, I want you to live until around this date. It's not exact, and then it will automatically delete that data for you if you want to have ephemeral data for some reason. Again, don't have to write code to do that. It's pretty cool. Obviously, queuing. I think a lot of people have queuing in their applications. I have seen handwritten custom queues built on top of databases, and I strongly recommend, again, unless that's your product, unless that's what's making you rich, don't do that. You don't have to use SQS. You could use RabbitMQ or something else. But if you require queuing, you want to use that as a service. Event filtering is a new feature for Lambda, where prior to event filtering being available, when you invoked a Lambda function off an event, you would have to then inside the Lambda function say, is this the event I wanted? Do I take the action here, or should I just exit, or should I throw an error or something like that? Event filtering says that you can filter the event attributes or the shape of the event before the Lambda function is executed. And again, you're saving money here, because if you say this isn't the event I'm looking for, then the function's not executed. Last fall, I think it was, Step Functions announced 200 new service integrations. So you can start to write functionless code. So you can say my state machine knows how to call the API gateway. It can put an event on Event Bridge. It can read from S3, all these different things. And a few of us have experimented with that a little bit, and some people have done some kind of cool things. It's not totally something that I think that you're ready to run off with, but there are some interesting possibilities there in terms of writing functionless code, so that there isn't actually any custom compute at all. But again, if there's no execution, if you're not running a function, then you're not paying for the compute. It still gets computed somewhere, but not on your bill. All right, I want to go into single purpose functions real quick here. So this is a typical kind of setup for microservices, where you've got some sort of internet gateway or something like that, and you got a path for customers, a path for orders, and then inside those applications, you're looking at the HTTP method and the path, and maybe some path parameters or some query parameters, and based on that, you're going to route to something inside of your application, right? So this is super typical right here. We've got two different web services that are taking traffic. Our gateway in this case is doing some high-level routing. It's saying, okay, customers go to customer service, orders go to the order service, right? But it doesn't do anything more fine-grained than that. This is kind of a typical setup for this kind of architecture. In serverless, you can do something like this. Now, this is not universal. Not everyone does things this way. You can sort of do serverless in the same way I just showed the last diagram, where you've got one function handler that kind of serves as a microservice and will take all the different kind of CRUD operations or whatever else you have there. But you can also do this, and actually I like to do this, which is single purpose functions. That means that the API gateway is saying, I'm going to bind this path, get customers ID, and it's going to call this function called get customer by ID. And inside the function, we can grab that path parameter and then execute the code, and so on and so forth with the other ones. Having for each of the actions that we want to take, there's a specific Lambda function that will be the handler for that. So let's just write very small amounts of code, very small functions. We don't have to write the routing inside of the functions. Obviously, we do have to write the routing in some sort of infrastructure as code, so that might be done in a SAM template or AWS CDK, which is my tool of choice. but it's pretty light work, and it can help us to have very nice, clean, small single-purpose Lambda functions. Let's talk about service limits. This is a good one. So all services have limits. If you call the service too many times in too short of a period, so maybe a second or whatever, you will start getting errors back. It will say, too many requests, call me back later. Every single AWS service will do this. I think all the cloud providers will eventually say, whoa, that's too much. You can't call me that often. And this is sometimes pretty annoying to developers when that happens to their applications. But you also have to think about that all systems have limits, right? Just because you custom built your system or you're running your own server doesn't mean now you can serve 900 trillion requests per second or something like that, right? You still have a limit. You just don't have a limit that's imposed by your cloud provider. Serverless developers learn these limits. You have to, and you might be annoyed by them. Sometimes you will really regret these limits, but you have to learn them, and you have to architect your application around them and understand what the limits are. You can't have service limits increased. Sometimes it sort of depends. I mean, that's another thing that you just sort of have to learn about. Some of them are easy to increase, and of course, the cloud providers are going to be happy to increase some of them because they're going to bill you more when you use the service more. You may have just heard a train in the background. I live by a train track. Okay, but now if we compare these two things, think about it. What is worse for you? Is it a few customers getting a 429 too many requests response, or your system crashing, right? Because the great thing about service limits is that the service will almost never crash because you'll never overload it, and that's a pretty cool thing. All right, I can see I'm pushing the my own service limit here, so I'm going to go a little bit faster. Noisy neighbor. So this is an example of Lambda functions with a service limit of 1,000 total concurrent functions executions here, right? So I've got process orders and notify customers. Notify customers is being really noisy and is taking all 1,000 of my concurrency, and now I can't process any orders. Serverless developers find ways to fix that. One way is with reserved concurrency, saying notify customers gets 500 of these executions and no more. Extra ones, hopefully we have some queuing or retry system here for notify customers. Hopefully we'd have that for process orders too. But that way we will always have the headroom available for process orders. Another thing I like to do if things get really noisy is I like to put my busy accounts, busy workflows in separate AWS accounts. So here, if we're in a multi-account kind of situation, I can have notify customers go completely berserk, but the service limit applies to that AWS account, and my process orders is just doing just fine. It's in a different account, and it has its own service limit. Orchestration versus choreography. A bit over step functions. Step functions is an example of orchestration. We have a single state machine, so everything's sort of centralized around that. This is good for a complex workflow inside of a bounded context, and it can even be executed synchronously, which is another cool thing. You put an API gateway and get the response back. Just make sure it's fast, otherwise your end user is going to be annoyed. Event Bridge is an example of choreography. It's more distributed. This is a great use case for crossing service boundaries, and you can connect different services together without having to expose implementation details. Great for big teams and for large complex systems. You can also combine these two ideas by connecting multiple state machines together with Event Bridge or comparable technologies, of course. Networking. All right. So I said, please don't bring your own network to serverless. And this is not universal, but a lot of serverless developers don't like to build networking abstractions on top of their AWS account or cloud account. Sometimes you have to. Sometimes you're running a resource that you need to work with, inside of some kind of networking abstraction, and you need to connect your function to that in order to call to it. But if you don't need it, most serverless developers will say you shouldn't use it. Traffic between your services are assigned and encrypted. So do you need to actually add additional security to that? I don't know. I'm not your auditor, but I tend to think not. Lambda, by the way, already runs in an AWS managed VPC. It is not just visible on the internet. But really, what this all comes down to is that the developer experience for serverless developers to interact with these networks is, at this time, it's not very good. That's really what bothers us, is that it takes a lot of extra work. We have to start thinking about IP tables and a lot of other things. A couple of years back, AWS fixed the fact that their functions running in a VPC were very slow, but interacting with VPCs and deploying into them and things like that, there can still be a lot of problems with it. Also, managed NAT gateway is very hated by serverless developers because it is not serverless, and you have to pay, I can't remember how much monthly for it, no matter what. All right, IAM real quick. So I showed this a little bit earlier. Roles and policies for resources to talk to each other are created and managed by developers most of the time when working with serverless. Each piece of the infrastructure gets a fine-grained role that allows it that describes what actions it can take. Now, this can be annoying to developers sometimes because your app isn't working and you can't figure out why. But it's actually a pretty good security model anyway. It's much better than, imagine if we had to manage secrets for all these different things. If we had to say, okay, let's generate a secret in Lambda, and then we're going to copy that into API gateway so that those things can talk to each other. And now we're going to generate a secret in SQS, and we're going to copy and paste that into a Lambda function so that it knows how to, trust me, that would be a lot worse. As long as we're talking about security, don't put your keys in GitHub. If you're on AWS, you should really be using AWS SSO. I never touch a key, and I'm able to get all the access I need. So real quick on, kind of how this works. I showed before this policy that gives my Lambda function read access to my DynamoDB table. So here it is again in the SAM template. When this is executed, we'll end up with something like what is on the right side of this. And you can see that it's abstracted, right? So you can write policies that look just like the right side of the screen. Most of the time we don't. Most of the time we have a nice abstraction like this. SAM has good abstractions. Serverless Framework has some good abstractions. AWS CDK, in my opinion, has the best abstractions. But all these are good abstractions, and they keep you out of having to write something that looks like on the right side, but does enable developers to correctly create the nice fine-grained policies that their applications need. And this is a good mix, in my opinion. Let's talk about item potency. So I talked about a little bit about eventing and events being delivered twice. Most of the time, when you're consuming events, there's no guarantee that the event will only arrive once. Sometimes messages are delivered more than once, and you should design your application to be tolerant of that. So DynamoDB is the most popular serverless database for AWS serverless developers. It has methods called put item and update item. Put item replaces an existing item, or it creates one if one doesn't exist already. Update item will either update a couple of fields on an item, or it will also replace the item. But there's no such thing as create item. There is no version of insert into that says I'm going to create a brand new thing absolutely every single time when I do this. So DynamoDB is sort of leading the way in item potence here, and I think that's significant. I don't think that's any kind of coincidence. And now when we're designing your application, think about, like, if we implemented a process payment, it's taking a customer ID and an order ID. What happens if this gets called twice? If this function it creates like a payment record or something like that, and then that record gets updated a little bit later to paid status, and then process payment comes again, and it says, oh, let's I just set that to pending, or if it creates a new payment record or something like that, is the customer going to get billed twice? You have to architect around this and think about, is there a way I can design my system such that that function could get called twice with the same arguments, and they don't get billed twice, because they'll be really bothered by that. There's a couple of tools out there that will give you an idempotent implementation. Basically, what it's going to do is it's going to hash the function call, and it's going to store that somewhere, and then it's going to let you know that has already been executed, and it's going to fail it. There's also FIFO queues, first in, first out. They cost a little bit more, and they're a little bit more complex. I would say design for idempotence if you can, but if you can't, then that's a good tool. All right, paper request and scale to 0. So a lot of times, if we're looking at some cloud service or some vendor that we're considering, we might see a screen that looks a little bit like this. Like, oh, look at this! I can get 4 virtual CPUs and 64 gigabytes, and it's going to cost me $19.99 a month, whether I use it or not, right? Whether I crash it, whether I never touch it again. Serverless developers like to see something a little bit more like this, where you're actually paying per request. And I think one of the reasons that we like that is because it lets us think about ephemeral environments. It lets us think about different stages that we can implement. It lets us think about build up, tear down, experiment. And we like that a lot because it's freeing, and it lets us build the best possible application. At the end of the day, which one of these is cheaper? I have no idea. I don't even know what this is. It could be that the one on the left is significantly cheaper than the one on the right, based on our usage pattern, and we should probably pick the one on the left in that case. But I'm just saying that the serverless mindset is going to tend to prefer the one on the right. Testing serverless applications. So serverless applications to make use of all kinds of cloud services. In some cases, we mock or emulate them. Some people think that's a good thing. Some people think that's not such a good thing. Most people agree that eventually you need to start testing in cloud. I like to have different environments and use different accounts so that I can kind of separate things out. When we're doing unit tests, sometimes we'll use mocks, sometimes we'll use emulators, or sometimes we'll connect to real cloud resources. You might have your compute running on your workstation, and you might have a key to a dev account that you're actively developing against. I love on-demand environments. Asynchronous workflows are really tricky to test. I don't feel like that's a totally solved problem, but there's a few of us. I did a blog post about that. A couple other people have done some really interesting work in that area, and I think we're starting to get that, but it's hard so far. What about testing infrastructure? I deployed something, and I want to make sure that everything connected together well. Now you could test the secondary aspects of that, but there might be some other things, like for example, I created an S3 bucket. I might want to test, is that public, right? Like that's one of the biggest vulnerabilities that people end up causing for themselves. So that'd be an example of the kind of infrastructure testing you might want to do. A lot of times when we're in serverless space, now I showed how we deploy all the infrastructure and the application together. So a lot of times we'll be building CI/CD. Some of the major frameworks have that sort of built in, and thinking about rollbacks and automation can really take you a long way. Developer experience. The kind of what, like all these things put together, the focus is, even though I'm really focusing on a lot of things that might be new to some people, once you kind of get that down, the purpose here is to move a lot of the undifferentiated heavy lifting into the cloud, and then focus on delivering value. And that's what the developer experience is all about. Is like, once you start to get this, once you get into the serverless mindset, then you can really just kind of start to focus on your application. Most people in the serverless space have a build, ship, run mentality, which means that we need to figure out how to support our applications once they're out. There's some new tools that have just come out: SAM Accelerate, CDK Watch. I think a few other frameworks have things that are a little bit like this, that do cool things, where they sort of, in a development, not production ever, but in a development cycle, it lets you short circuit your deployment, and your code can very quickly update, and then you can basically be testing in the cloud. A lot of times I think this is a little bit of an unsolved problem, in that the user experience around things like secret manager and parameter store and some of these other things isn't really ideal, but that's still the way we want to go. We don't want to implement our own config and secrets management. We want to take advantage of these cloud services when we do this. Lambda Power Tools is a nice, cool project that adds to the developer experience and tries to promote some best practices. Observability is a big thing in this space because our applications are so distributed, and we need to have a really good idea of what's going, how many orders did we process, that kind of thing. And I think when people say, well, wow, what this is like, there's so much going on here. How do you have all of this in one developer? Or what about operations? What about some of these other traditional roles? And I think that there's still room for everyone shifts slightly, and we all have to sort of be a little bit more familiar with the application, or a little bit more familiar with the infrastructure, and we develop those T-shaped skills. So like me, for example, I'm not very good with networking. You may have picked up on that when I was talking about the networking stuff and not liking it. Well, I mean, like not everyone can be good at everything. And that's why we form teams. But I always like to encourage people to, find the thing that you're good at. Be familiar enough with everything else, but really go for that thing that you're best at. Okay, how to get started in serverless. First of all, use a framework. This is a bunch of frameworks. I'm sure there are other frameworks that I left off. They all have great starter kits. They're all really good. They're different in different ways. Some of them you might not like. Some of them you may love. But if you're going to work in serverless, use one of these things. If you have an existing application and you're like, well, I can't just throw this in Lambda, you're probably right about that. But you can do some really interesting things around the edge of your application. You can, like, if you have some kind of cron process as a great candidate for updating to step functions, or update some sort of workflow. That's how I got my start, and my team got our start. And once we became more familiar with these things, we started doing more and more interesting things to our application. You should also be looking for community. I literally joined Twitter because of serverless, because that's where everybody was, and I could start to interact with some of the awesome AWS heroes and some of the other people that have some really great ideas there. I'm going to just shout out to my cdk.dev people here. There's a great Slack community that's totally open. If you're interested in CDK, they do non-serverless things there too, so be warned. But it's really cool community. And then finally, AWS Community Builders. Not a totally open public organization, but like I said, we do open enrollment twice a year.
So Matt, quick question from the audience. So of those frameworks you had on your last slide, is there a framework that you use or recommend personally? So
I literally do think that these are all good. Like you couldn't really go too wrong with one of these. I've used SAM a little bit. I prefer CDK. CDK lets me write my infrastructure. Sorry, I've got another screen in the background. CDK lets me write my infrastructure in TypeScript, and I like writing in TypeScript. I like that better than YAML. It sort of fits my mental model a little bit better. So that's the one I like. I've been playing with Serverless Stack a little bit, which is a framework on top of the CDK, and it has some other really cool things, but I haven't done a ton with that. These are all good. So I think find the one that fits your mindset, and you will like it. This is my last slide, really, though. So I know I was rushing to try to get through everything. Serverless gets better with time. That's another thing that serverless community loves about serverless. Microsecond billing is an example of that. Lambda used to bill by the second, and then they just cut it over to microsecond billing. So all of your bills now are smaller. It's awesome. New extended processing time and instance sizes in Google Cloud Run and AWS Lambda. I mentioned the step functions, service integrations. That was a new thing that came out recently. ARM64 processors dropped last year. That let us use the new chip in Lambda, which was really fun. I mentioned event filtering. That was another thing that we got for free. These are awesome because if you're using a native service, you're using cloud service, you just eventually start getting these capabilities. You don't have to use them, but they become available, and you don't have to do some big migration. You don't have to upgrade your instance versions or anything like that. They just simply become available. All right, thank you. I know I was shooting words at you like crazy. I really appreciate the opportunity to do this on the show. This was really a lot of fun for me. And I appreciate especially my AWS Community Builders and all the people that encouraged me to come and do this. So thank you.
Hey, thanks very much, Matt. Great job. And hey, for anybody who thought it went by too fast, don't worry. You can just go view this on YouTube in a day or two when we post it up there. And for those of you watching YouTube, we will put a link in the description to Matt's website, so you can go view these resources after the fact and rewatch this and click whatever links he puts in there. So thanks again, Matt. I'm looking for last questions. I don't see any. Just a bunch of thanks. Great presentation, all that kind of stuff. So I think we'll go ahead and wrap it there. Thanks a lot.
Thank you.